So now, whatever the question they had given, what they're asking finally means they're asking to calculate the average rate of reaction in terms of hours, minutes, seconds. And what is the rate of production of the NO2 during the period? So first thing, so they're asking to calculate the average rate of reaction. So to calculate the average rate of reaction means first, before that, first better you write as a rate expression of the given equation. Who's going to tell the rate expression of the given equation? Kathy, can you tell me the rate expression of the given equation?
Sir, 1 by 2 delta N2O5 by delta T.
Very good, ma'am. So minus 1 by 2 delta N2O5 by delta T is equal to
1 by 4 delta NO2 by delta T.
delta NO2 divided by delta T is equal to delta
Delta O2 by delta T.
delta O2 by delta T. So this is the rate expression. Okay, and in this one first we have to calculate this value. So which one by which value we have to calculate here? So minus 1 by 2 delta N2O by delta T value we got here. So this it represents as the average rate of reaction. Sir, why we are taking as a minus means minus it signs as a decreasing the concentration of the reactant. Minus it signs as here decreasing the concentration of the reactant. Sir, average rate of reaction. How we can calculate the average rate of reaction means final concentration minus initial concentration by final time minus initial time. According to the question, they had given us a delta T value. So how much they had given us a delta T value? 184 minutes they had given. Okay, and initial concentration. So how much initial concentration? X1 they had given as how much they had given? 2.303 mole liter inverse. And what is the X2 value? X2 values they had given as so 2.08 mole liter inverse. So based on that one, how we can calculate? Okay, how we can calculate the average rate of reaction? How we can calculate the average rate of reaction means average rate of reaction is equal to minus 1 by 2 into in this one x2 minus x1. What is the x2 minus value? 2.03 minus 2.33 na sorry my here 2.33 2.33. So divided by 0.8 2.08 minus of 2.33 divided by 184. If we simplify that one means how much value you get. If we simplify this one means how much value you will get. Can you simplify and tell me the answer? Kathy, Aditi, Samhita, Ritu.
Yes, sir, got it.
How much you got, ma? Samhita. What is the value you got? I think so. We may get us here 1 by 8 into 184. You may got. Okay.
But I got it as 6.79.
6.797 into 10 power
minus 4.
Very good one. 10 power minus 4 is the answer here. Okay. So what is the average rate of reaction? What is the average rate of reaction means here 6.7 into 10 power minus 4 mole liter inverse and second inverse. Okay, so mole liter inverse second inverse. So this one is so actually it is not the second inverse, it is the minute inverse because so we had taken as a 184 minutes now. So what they're asking the question here, they're asking is here we can calculate the minutes, hours and seconds also. So this one is minutes here. This one is here minute inverse. If you want to calculate in hours, hours means how we can write here 184 divided by 60 because of 1 hour is equal to 60 minutes. Total minutes, total how many minutes they had given? 184. So 184 by 60 means how much will get, ma? 2 3s 0. So 2 9s 2 2s. Okay. And 92 by 30. 92 by 30 means how much will get? 92 by 30. How much will get the value?
So 3.06.
Very good, ma. If it is 3.06, sir. Okay, 3.06. If it is 3.06, so that means what is the answer we'll get as here? 1 by 8 into 3.06. If you simplify this one means you will get the answer in hours. Whatever the answer you are getting here, that it will be in hours. Okay, and seconds also they're asking. Seconds means what happened in this one only if you multiply with 60 means. So you will get the answer in the seconds also now. Okay, so whatever the answer here divided by 60. If you place the 60 means you will get the answer is here seconds. Okay, but we can take as a minutes by here. So what we can take as a minutes. So what are the answer? We got the average rate of reaction in a minutes means 6.7 into 10 power minus 14. Okay, so what is the average rate of reaction? Is that here 6.7 into 10 power minus 15. And what is the question they're asking? So one we calculated. So we calculate the average rate of reaction. Okay, average rate of reaction of N2O5 we calculated. So then we have to calculate the, sir, what is the question? Can I show one second? What is the second question? What is the rate of production of NO2 during the period? How we can calculate the production of the NO2 during the period? NO2 during the period. How we can calculate the NO2? For that one, comparison method. So how we can calculate means by the comparison. Okay, to compare means compulsory rate expression is very, very important. Na? Okay, so rate expression is very, very important. So what is the rate expression you wrote as here? You wrote as a rate expression is equal to second calculation. So you wrote as a 1 by 2 into delta N2O5 divided by delta T is equal to 1 by 4 into del NO2 divided by delta T. Got the clarity? Okay. Now in this one, we know the minus of 1 by 2 del N2O5 divided by delta T. So what is the minus 1 by 2 del N2O5 by delta T value in minutes? How much we got my answer in minutes? 6.7 into 10 power minus 4 is equal to 1 by 4 into del NO2 divided by delta T. But what they're asking the del NO2 divided by delta T value. How much production of the NO2 they're asking here. Okay, to simplify that one, what we had to do, we had to send the 4 in this side. So if you're going to send in this side means here, it becomes as a, sir, numerator. It comes into the numerator. It comes into the numerator means it becomes 6.7 into 10 power minus 4 into 4 is equal to del NO2 divided by del T. If you multiply the 6.7 into 4, how much you will get, ma? What is the answer you will get? What is the answer you will get? 6.7 into 4.
26.8, sir.
Very good, ma. So 26.8 into 10 power minus 4. .8 into 10 power minus 4. So this also can be write 2.6 into 10 power minus 3 also we can write 2.68 into 10 power minus 3 also we can write or not, ma?
Yes.
Okay, so this also we can write as a 2.6 into 2.68 into 10 power minus 3 also. To make you confused, sometimes they'll change the decimal point in the examination. In the option, they change the decimal point. Got the clarity? Okay, now you understood?
Yes, sir.
Okay, so this kind of calculation also it is there by here. Okay, if in this one, why I wrote as a rate expression means, if you know if you know how to write the rate expression means, okay, so if you know one thing means we can calculate the another one concentration also. Okay, so based on that one previous year question, so many are they're asking here. In NEET and JEE also they're asking. Now you got the clarity for that one. So first, in academic textbook also we have some questions based on this one. So can you practice first that questions here? All of you are using some academy books and someone they're using as some modules and their school materials also they're using here. Okay. So every material it is a common question. This question it is there in all the materials. In all the materials you have this question. Okay. So based on this one, some other additional questions also they had given that you can practice. Okay. So physical chemistry, chemical kinetics, very, very important. The NEET level and JEE level. Okay. And that is also numericals are very, very important. Sir, when we can solve, how we can solve the numericals means, now if you understood this concept, is it right? Everyone? Now you understood or not how to calculate and all?
Yes.
Okay, now you understood. Okay, immediately if you practice means you are able to solve the questions. Otherwise, after 2-3 days now, if you're trying to solve the questions means you will get little bit confusion. Okay, now we finish the concept. Better to try some questions based on this one. Okay, that will go for the another concept. So what is the another concept means? Yeah, rate law or rate expression. So where we are getting as a rate law or rate expression means here we have some concepts. So what are the concepts means here? Factors affecting the concentration of the factors affecting the rate of reaction. Okay, factors affecting rate of reaction, affecting rate of reaction. Factors affecting the rate of reaction. So what are the factors affecting the rate of reaction means here? So 4 factors are there that affects the rate of reaction. In that one, first factor is concentration. First factor is concentration of the reactants. Second one, temperature. Second one, temperature. So third one, pressure. Okay, third one, pressure. So fourth one, okay, catalyst. Fourth one, catalyst. Okay, so in this one deeply we can study one by here. In this one, first one we are taking here. So what is the first factor we are taking means concentration. Okay, concentration. Actually, what is the general concept for the rate of reaction and concentration means here? Rate of reaction and concentration are directly proportional. If the concentration is going to be increases, rate of reaction also is going to be increases. According to that one, how we can write as here? So rate is directly proportional to concentration. We can write as here. Okay, rate is directly proportional to concentration. So that means that the concentration is going to be increases. Rate of reaction also is going to be increases. Okay, here only. So we are going to study about the rate law or rate expression also. Okay, rate law or rate expression also we are discussing. Rate law or rate expression. Rate expression. Okay, so based on the concentration term. So based on concentration term. Okay, so according to the concentration term, the rate of reaction is directly proportional to molar concentration of the reactants. Okay, so according to the concentration, the rate of reaction is directly proportional to directly proportional to okay, directly proportional to molar concentration of the reactants. molar concentration of reactants. Okay, so for example, now I'm taking as some chemical equation. So I'm writing as some chemical equation. What is the chemical equation I'm writing? Means here A moles of the A is reacts with small b moles of the B to form as a small m moles of C, m moles of the C plus, and n moles of the D product it is going to be formed. Okay, in this one, what are the reactants are there and what are the products? So which we can call as a reactants and which we can call as a products, ma?
AA and BB are the reactants. MC and ND are the products.
Okay, MC and ND are the products here. Okay, according to that statement. So what is the statement is that rate of reaction is directly proportional to the molar concentration of the reactants only. So that means how we can write the rate expression means here rate is directly proportional to molar concentration of the A raised by their stoichiometric coefficient and B molar concentration of the B raised by their stoichiometric coefficient. Okay, sir, what are the stoichiometric coefficient values we had taken? A and B, A plus B. So A plus B, it may be equal, may not be equal. Okay, it may be equal or it may not be, it may not be equal to the stoichiometric coefficient, to the stoichiometric coefficients. Okay, coefficients. Okay, stoichiometric coefficient. Sir, why you are telling that it may not be equal to the stoichiometric coefficient? Means because of rate of reaction is directly the rate of reaction is based on the experiment, my here. It is not the theoretical base. Okay, so rate of reaction is it's completely experimental base. It is not the theoretical base. So due to that reason only, what are the stoichiometric coefficients are there may or may not equal to the stoichiometric coefficients. Okay, so that how we are going to divide means based on the experiment. If in the experiment, what are the value you got based on concentration of the A, concentration of the B, that we are going to be right. Clear? Now, let us see. So to remove the directly proportional, so we have to take as a some constant value. So what we can take as here, so rate is equal to K into molar concentration of A to the power of A and B to the power of B we are writing. In this one K, so K is nothing but one constant. So what is the rate constant means here? This we can call as a rate constant. This we can call as a rate constant. Okay, so based on this one, how we can find out the rate units of the rate constant? Units of rate constants. Units of rate constant. Okay, so before going to the calculator of the rate constant, units of the rate constant, how we can write the formula for the rate constant? How we can write K is equal to rate divided by molar concentration of the A and molar concentration of the B. So that means in place of that one directly I can write as a concentration of the reactants. Concentration of reactants. Okay. So how many reactants are there means that we can take as a n power. Okay. How many reactants we are taking means here power n number of the reactants are there. Okay. Now based on this formula, how we can derive the units for the rate constant? First of all, what are the units of the rate ma? Units of the rate of reaction. Units of rate of reaction. We discussed in the class.
Molar liter inverse second inverse.
Mole, liter inverse, second inverse. Very good, Ritu. Okay, so very good, ma. So what are the units of the, so rate means, so units of the rate is mole, liter inverse and second inverse. Okay, now, so you're telling that. And concentration of the reactant. So concentration of the reactants also we can write as here mole, liter inverse to the power of n. To the power of n. To simplify this one, ma. So to simplify this one means how we can write as here mole, liter inverse, second inverse divided by, so mole to the power of n, liter to the power of minus n, liter to the power of minus n. Okay, if if the denominator A by B value is there, okay, A by B value, okay. So this also, if A comes to the numerator, A it is there, A to the power of M and A to the power of N value is there. So this how we can write, ma? A to the power of M divided by A to the power of N. This how we can write? How we can write this formula? How we can simplify this formula? This formula we can simplify A to the power of M into N only, M plus N only, na? A to the power of M plus N. A to the power of M plus N. Okay. So according to that one, how we can write the equation? According to how we can write here. So mole it is there. So mole means, if we simplify this one, means mole to the power of 1 to the power of 1 minus 1. So that we can write as a minus 1 minus N. And liter, already minus 1 it is there. If minus N, it comes to the numerator part, means it becomes as a plus N. According to that one, how we can write? So liter to the power of N minus 1 and second inverse is the common. Okay. So this is the general equation for the rate constant of the rate of reaction. Okay, so this is the general formula. If you know this formula, means so we can find out the rate constant of the different types of the reaction. Okay, so we have a different types of the reaction. So what are the different types of the reactions we are having? Means here we have a zero order reaction, first order reaction, second order reaction. Okay, according to that one. Sometimes if they ask the question, so what are the units of the rate constant? Units of rate constant of zero order reaction. Okay, zero order reaction. Sir, what is the rate constant of a zero order reaction? Means in this one, first you have to know the N value. Sir, what is the N value? Means N is equal to 0, 1, 2, 3, 4, like that. Now they're asking the zero order. In this one, what is the N value? N value, it becomes as 0. In the zero order reaction, N value, it becomes as 0. So according to that one, what are the rate constant units of the zero order reaction? Any one of you? What are the units of the rate constant of the zero order reaction? Okay, for zero order reaction, N value is equal to 0. Ritu is giving answer.
Mole liter inverse second inverse.
Mole, liter inverse, second inverse.
Second
Very
inverse.
good one. Very good one. Next, Samhita. So my question is, what are the units of the first order reaction? Rate constant units of the first order reaction.
Second
In first
inverse.
order, very good one. So first order reaction, n1 n is equal to 1. So that means we'll get as a second inverse because of 1 minus 1 is equal to 0. Liter is equal to 1 minus 1 is equal to 0. Okay. So liter to the power of a power 0 is equal to 1. So that's why directly we can take as a second inverse. And Kathy. So what are the units of the second order? Second order. Rate constant of the second order.
Sir, mole inverse, liter second inverse.
Mole inverse,
Liter second inverse.
liters, second inverse. So all of you got the clarity how we can calculate the units here. Rate constant units of the first order, second order, zero order. Okay. Aditi, what are the units of the third order reaction? Third order reaction. Aditi. Aditi is there or not? Aditi. Aditi, are you getting my voice or not? Okay. I think so. Samhita, what are the units of the third order reaction, ma? Any one of them?
Sir, is third order, will they give third order reaction questions?
No, ma. So actually, JEE level means general concept, na. That's why I'm asking here. So because of N, maybe it may be 0 or first or second or third order here. Okay. So generally they're asking.
Sir, can I answer?
Okay. Ah, tell me, ma.
Sir, is it mole, square inverse, liter square, and second inverse?
What is the in third order reaction? What is the n value? N value is equal to 3 only, na? N is equal to 3. If n is equal to 3 means what happened here? So mole to the power of -2, liter to the power of 2, and second inverse. So this is the equation. What are the units of the third order reaction? Okay, so you are using as a some order. What is meant by the order? So before going to the order, before going to study about the order, first we have to some terms. So what are the terms we have to know means here? Point number 1. Elementary reaction. So what is meant by the elementary reaction? Anyone of you? Elementary reaction. What is meant by the elementary reaction? Any one of you? Elementary reaction. So what is meant by the elementary reaction? Elementary reaction is nothing but the reaction which completes only in one step, only in one step is called elementary reaction. Is called elementary reaction. Okay, so what is meant by the elementary reaction means here? So the reaction, so the reaction which completes only one step is called as a elementary reaction. Okay, so next one. So what is another one means here? Complex reaction. Complex reactions. So what is meant by the complex reaction? Any one of you? Elementary reaction means we call as the reaction which completes only one step is called as elementary reaction. And what is meant by the complex reactions? Complex
Which
reaction.
takes many steps to complete.
Very good, Ritu. So which takes more than one step. That means the reactions which completes more than one step, which completes in more than one step, is called complex reaction. It's called complex reactions. It's called complex reactions. Okay, in this only one unit is there. Okay, so rate determining step. So which we can call as a rate determining step. Rate determining step. Okay, so what is meant by the rate determining step? Okay, so what is meant by the rate determining step? So what is meant the rate determining step? Where you got this one means here. So hello alkenes, hello arenes chapter is finished. Hello alkenes, hello arenes. We are studying about the reaction intermediates. So there you are getting as a rate determining step. What is with the rate determining step means here? In a slow step, okay, the slowest in a complex reaction, the slow step is called rate determining step. Rate determining step. Okay, in a complex reaction, because of in a complex reaction means the reaction is going to be completed more than one step. Okay, so one step it may be very fast, one step it may be very slow reaction it will be there. So whatever the slow step it is there, that is only we can consider as a rate determining step. Okay, so based on this one, we are going to discuss about the order. We are going to discuss about here order. Okay, so order and molecularity. So directly, shall we discuss about the difference between the order and molecularity, ma? Okay, order and molecularity. Okay, so both at a time I'll discuss here. you will get the clarity without getting any confusion. Okay. Now, sir, first of all, so what is mean by the order? What is mean by the order means it is sum of powers of molar concentration of the reactants. Molar concentration of reactants in a rate law or rate expression. Okay, sir, what is meant by the order means it is the sum of the powers of the molar concentration of the reactants in a rate law or rate expression is called as a order. Okay, sir, how we can calculate means here now only we wrote as a rate law. How we can write as a rate law? So rate is directly proportional to molar concentration of the A to the power of A and B to the power of B we wrote as here. In this one, what are the powers it is there? A and B. Okay, it is the sum of A plus and B is called as an order. Okay, the sum of A plus B is called as an order. Okay, order it may be fraction, it may be fraction 0, okay, 1, 2, 3 also it will be there by here. Okay, and order of the reaction. So order of the reaction is completely experimental base. It is completely experimental base. It is not the theoretical based. Okay, order of the reaction is completely experimental base. It is not the theoretical base. Okay, now we will discuss about the molecularity. Sir, what is meant by the molecularity means the number of atoms or molecules involved in elementary reaction. Involved in elementary reaction. Elementary reaction is called molecularity. Sir, what is the example means? For example, 1 mole of the hydrogen gas is reacts with 1 mole of the iodine. It forms as a 2 moles of the hydrogen iodine. So in this reaction, what is meant by the molecularity means here? So molecularity becomes as a 2. Sir, how you are telling that molecularity is equal to 2 means here based on the chemical equation. In a chemical equation, how many number of moles of the reactants are there? That only we can consider as a molecularity. So based on that one, what we can say? So molecularity is completely theoretical based. Okay, and molecularity it may be, sir, it may be, okay, it may be 1, 2, 3. It never be 0. Okay, it never be 0, and fraction. Okay, never be 0 and fraction. The maximum molecularity is 3. What is the maximum molecularity means here? Maximum molecularity we are taking as a 3 is the answer. Okay, so more than 3 if you take means we can't find out the reaction mechanism. It is very difficult to find out the reaction mechanism. So whenever it is having the 3 molecule means based on that one only we can find out the rate of reaction. Okay, until here if you are having any doubts, once you check out, also I explain a little bit fast because of I'm going very slow. So today I explain a little bit fast only.
Sir, is there a maximum for order also?
No, ma. We can't find out the maximum.
More than 3.
Ma.
Order can be more than 3 also.
Order it may be more than 3 also it may be there. Okay. Sometimes both the molecularity and order also it becomes as the same value. Order and molecularity also it may be same value it will be there. So because of order we cannot find out here. Order is completely experimental based. It is not the theoretical base. Okay, but molecularity is completely theoretical based because of we have a unimolecularity is there, bimolecularity is there, trimolecularity reactions are there. Sir, what is remember the unimolecular reactions means here? So what is the best example means? We have one example, unimolecular reactions. What is the best example of the unimolecularity reaction means? So 1 mole of the NOCl, 1 mole of the NOCl, NOCl is it undergoes to the decomposition reaction. It forms as a nitric oxide gas plus half mole of the chlorine gas is going to be formed in this one. What is the molecularity means? What we can say, ma? What is the molecularity in this one? How many moles of the NOCl we had taken?
1, sir.
1 mole. Hence, the molecularity is equal to 1. Hence, the given reaction is called as a unimolecular reaction. Okay. Hence, the given reaction is called as a unimolecular reaction. For example, in this one, 2 we had taken. 2 reactants we had taken. Hence, in the given equation, the molecularity is equal to 2. In a given equation, the molecularity is equal to 2. Okay. For example, if I wrote one more thing here. So, what is another one means here? If we take 2 moles of the okay, so 2 moles of the sulfur dioxide gas it is there. It is reacts with 1 mole of the oxygen gas. If it is reacts with 1 mole of the oxygen gas means it forms as a 2 moles of the sulfur trioxide gas in a given chemical equation. So what is the molecularity? Anyone
3,
know?
sir.
Very good, Ritu. So what is the molecularity in a given chemical reaction means here? 3. Sir, how you are telling that means based on the elementary reaction. Okay. So what is the elementary reaction? Means the reaction which completes only in one step is called as a elementary reaction. Now in a chemical equation, 2 moles of the sulfur dioxide gas is combines with 1 mole of the oxygen to form as a 2 moles of the sulfur trioxide gas. Okay. So in this one, what is the molecularity means? Molecularity we can say as a 3 only. Okay. So this question ma for board exam also they're asking. Okay. What are the difference between the order and molecularity also?
Sir, can you explain that example again? Shouldn't the molecularity be 2
Which one ma? Molecularity?
for SO3?
HO3 ma. Okay. Now let's see ma. So how many moles of the sulfur dioxide you had taken ma? Kathy?
2, 2,
2
sir.
moles. How many moles of the oxygen it is there ma?
1.
1 mole. So total number of molecules
Oh,
3.
oh.
So 2 plus 1 is equal to 3 now. Hence the molecularity becomes as a 3. So to make you clarity, I'll give one more example, sir. So what is the example means? 1 mole of the nitrogen gas reacts with 3 moles of the hydrogen gas to form as a 2 moles of the ammonia. Okay, 2 moles of the ammonia. So what is the molecularity in a given reaction? What is the molecularity in a given reaction? Any one of it. What is the molecularity? Options 1, 2, 3, 4. Because of molecularity, it never be 0. At the same time, it never be fraction also. Okay, it never be it is a fraction. Then my question is, so what is the molecularity in a formation of the ammonia?
Sir, is it 3?
3 ma. How it is 3 ma? Ritu, once you check it out, number of moles only na. Nitrogen, how many moles we had taken? So we had taken as 1 mole of the nitrogen gas. And how many moles of the hydrogen gas it is there? 3 moles it is there. 3 moles of the hydrogen gas, ma. 1 plus 3, how much? 4, ma. Molecularity is equal to 4, ma.
Sir, you said the maximum is only
That is
3.
just the maximum.
Maximum is equal to 3 only. Maximum is equal to 3 only. Okay. But generally, I'm asking here. Generally, I'm asking. So because of it is a theoretical, it is the equation based, it is there. Okay. So for that
Sir,
one break. Amma, Kathy, you were
first,
asking.
for the first example, shouldn't the molecularity be 3 by 2?
Which one? This one, ma?
Yes, sir.
So because of it here, molecularity never be fraction, ma.
So it's
Molecularity
0.
never.
It can't
Ah,
even be 0. Oh.
okay, molecularity never be fraction. We can't take as a fraction. Okay, so if you are getting doubt means I'll give one more example for this clarity here. Okay, for example, 2 moles of the hydrogen iodide, it undergoes to the decomposition reaction. It forms as a 1 mole of the hydrogen gas plus 1 mole of the iodine gas. In this one, what is the molecularity? In the given reaction, what is the molecularity?
2, sir.
2 only. So how you are telling that 2 based on the chemical equation only, na? In a chemical
Yes,
equation, how many moles of the reactant we had taken? That is only it becomes as a molecularity only, na?
yes, sir.
Okay, so that is the reason here. So generally I explain here. So because of I told maximum molecularity is equal to 3 only. But okay, so why the maximum molecularity we are taking as a 3 means here? Because of rate of reaction is going to be decreases. Number of molecules are going to be increases. Rate of reaction is going to be decreases. Okay, some number of collisions will be given. Next upcoming concept we can learn clearly. Okay. So for Sunday exam, until here I am giving for the exam. Okay. So prepare and you can write on Sunday exam. And tomorrow and day after tomorrow I won't be available. Okay. Again we will meet you on Monday. Ma. Okay all.
Okay, sir.
Thank you all. Okay. Thank you.
Thank
Ma.
you, sir.